There are x-intercepts. So you can't see it, but this is one that you had to know. All right, so this is the parent graph is the square root, right? It starts out at 0, 0. And it's moved left 1 and down 7, right? So left 1 down. I'm somewhere around here. And so this graph kind of does this, right? This is inching up as you go. No, you can't see it on your graph, but just because you can't see it on your graph.
So how am I supposed to know what?
How do you? How do you find an x-intercept? How do you find a y-intercept?
You put it to your calculator, Mr. Gage, and it gives you negative 0.85.
Algebraically. Plug in 0 in for the x's. So if I want to find the x-intercept, so if I make this 0 equals 1/2 square root of x plus 1 minus 7, how do you solve that for x? Plus 7 times by 2. I'm trying to solve for x. What's 14 squared? 190 something. Yeah. When?
What are we doing?
You could, but you'd have to go all the way over to 195 to see it. Yes, they did. Several people got it. Who got that right on the x-intercept? There you go. 1, 2, 3.
1, 2, 3. Yeah.
Who's the other?
That's right.
Teach me how to do math.
You are. It's called a test.
That's not how.
Wait, what's the grade going to be for the Khan Academy?
I don't know yet.
Is
Okay.
it going to be a grade?
Same thing with y-intercept, but you can put a 0 in for the x, and you get 1/2 square root of 0 plus 1 minus 7. 1/2 square root of 1 minus 7, which is 1/2 minus 7, which is negative 6.5.
How did I get?
I don't know. You probably used your calculator, or you probably will.
Oh, I just saw the line.
Because that is, yeah, that does show up. Well, yeah. That is absolutely the lowest the graph ever goes, right? It doesn't necessarily have to be. It can be the lowest point on the graph, yeah.
Like, you did all the...
X-intercept was 195.
To find that x-intercept, to find the x-intercept,
The end behavior was something a lot of you missed also on this one. As x approaches infinity, we put 0 in for y and solved it for x. What is?
How'd you put 8?
So I put a 0 in for y and then just solved it for the x. So added 7 to both sides, multiplied by 2, squared it, and subtracted 1. As x goes to infinity, f of x, so on the right side of the graph is still going up. And on the left side, well, there is no left side. X never goes to negative infinity. Instead, x goes to a specific point. So as x approaches negative 1, what does f of x approach?
Negative 7.
Negative 1. What? I'm sorry. I did not.
Lots of you did do that on that part. So, okay, so end behaviors describe the ends of the graph. Okay, this end is pretty easy because, and I'm always using x to describe, and then I'm telling you what y is doing there. So on this end, X is going to infinity. X is getting bigger and bigger and bigger. That means the right end of the graph. The further I go right, what's happening to the graph? Is it going up, down, coming to a number? What is it doing? It's going up, right? It's not going up very fast, but whenever we start talking about infinity, if I go out forever, then I'm going to be going up forever. So that's why it's positive infinity. But the second one, when I look at the other end of the graph, it's not going forever and ever and ever. In fact, it dead ends at a point. So at that point, as x gets closer and closer to -1, I'm trucking, y is getting closer and closer to -7. And that's where it'll eventually just boom, stop. Yes. All right, flip it over on the back. Anything on the back?
Oh yeah, can you draw the graph for 8 and 6?
I'm pretty proud of it. I know that one all.
All right, so a lot of you on 6, you put the parent graph, but you didn't do the transformations on it. So the parent graph is that reciprocal where I have the asymptotes at the x and the y-axis, yes? And so this one has been slid to the right 5. 1, 2, 3, 4, 5. And up, where am I at? No, down 1. Which has essentially moved my asymptotes as well. So there are my new asymptotes. So if you weren't slid that way, then you were off to start with. If you went into if you used your calculator to plug in points, you'd get that it looks like this. To save some time, I won't find those individual points for you. So we can do some analysis here. All right. Domain. Everything except 5. A lot of you put everything except 0. That's the domain of the parent, but that's not the domain of the transformed graph. So domain here is going to only leave out 5. Whereas the range leaves out what? -1. Yes. Well, I mean, it depends on what you put in your calculator. Did you put 1 over x in your calculator, or did you put 3 over x minus 5 minus 1 in your calculator? And when you put it in the calculator, be very careful, because if you do this, you have to put parentheses around this denominator and around this whole fraction. Huh? Because from the bottom up, so I go up, but whenever I hit here, that's an asymptote, and it could never be the asymptote. X-intercepts, again, you could use the calculator to find it, second trace, and use that to find your 0, or you could plug in a 0 for y, and you could solve it from there. I don't remember what it was. Let me just do it. I would have to cross multiply here and get x minus 5 equals 3, so x equals 8.
You can round 6 points.
Around 0.5.
Yeah. And then the y-intercept, of course, I'm just putting in a 0 for x then to find that. And again, you could use your calculator for this, but I don't even have a calculator. That my altitude is stolen the calculator.
Who wants the ball away?
Right. That's a 5, not an S.
-8. That's what I wrote.
-8 fifths, not -8 1/2, -8 fifths. It's negative 1.6. See, negative 1 and 3/5. 3/5 is 0.6.
Too bad this graph is right.
Extrema. None. I don't have any because my function is actually always decreasing. Which gets us to increasing. What are the increasing intervals? None, because it never goes up as I move left to right. Decreasing. I gotta get my yardstick back.
Whatever I said, no, look, she gave me for you. She didn't give me those 2 points.
Decreasing is going to be negative infinity to 5. If it's always decreasing, then all I have to do is copy my domain here. No.
Seriously though? You didn't give me those 2 points?
How do you know what I gave you points for?
Because you do a check thing.
Unless
Count
it's
above the check.
circled,
Count above the check.
I don't do it. I count the negatives, not the positives. Okay. In behavior. This is the hardest in behavior on the quiz. Because look how many ends I have. 1, 2, 3, 4. Okay? All right. I'm going to do this in first. As x approaches infinity, I don't know, but y'all just crack yourself up, don't you? As x approaches infinity, so the farther I go to the right, what's y getting closer and closer to? So this is to infinity, so that's furthest to the right. Y is getting closer and closer to what? Negative 1. Look, it's getting closer and closer, and it's hugging this asymptote all the way down, but it never crosses. So as x goes to the right, the graph gets closer and closer to negative 1. The further I get right, the closer it gets to negative 1. Will never be negative 1, but it doesn't ask me, does it equal negative 1? It says, what does it approach? It approaches negative 1. All right, let's do the other far end. As x approaches negative infinity. So the furthest left you can look and then keep on going that way. What am I getting close to? Get out of my desk, Davis. Negative 1.
I still don't understand.
The farthest left. So, yeah. The order doesn't matter which ones you do it in. Just make, yeah, as long as you get them all. All right. Now I'm going to do the little bit harder ones. These ones in the middle, right? This end right here, this is x approaching 1, 2, 3, 4, 5, but it's coming in from the right side. Okay, so I say as x approaches 5 from the right, because you see it's different as it approaches from the right or from the left. So as I approach from the right, what's the graph doing? Positive infinity. It's going up, right? Bro, just look at it. Oh, look at there, so I see. Okay, as x approaches 5 from the
Right, or left.
from the left, which I need the negative sign, what's the graph doing? Because it's going down. Yeah. What else on the quiz?
7.
You don't get which part? Okay, so whenever you think about approaching x, you're talking about what it's getting close to as you come in, right? And if you look at when x is 5, there's 2 different sides that it comes in. Here, it's still approaching 5, but it's approaching it from this side, right? And this one's approaching 5, but so I couldn't just say as x approaches 5 because you'd say, well, but wait. Sometimes it goes up and sometimes it goes down, so you have to specify which side you're talking about. positive side, this is the negative side. That's not smart. Yep.
This one actually gets off.
If they ever overlap or like that, it's not right.
Yeah, they're supposed to be, aren't they?
None of those are cut off, bro.
That's what the calculator says. Calculator's got a bigger brain than I do.
Did the calculator put domain restrictions in on the calculator? Exactly. Got it. Somebody said, hold on. Oh, okay. Let me just quickly graph this one. This is the cubed root. It's cubed root. It's been shifted. Now think about what cubed root looks like. This is cubed root, right? It's been shifted down 2, and then it's been reflected and horizontally shrunk. Okay. So when you graph this, you should find that this middle point is now down 2. Here's my middle point now. And all I did when I did this one, because I wasn't real sure, I didn't want to worry with stretching and shrinking those points. I just picked a point on either side to plug in, kind of figure out what it was doing. So if I plug in 1, what do you get? Actually, I think I plugged in 2. Negative 2. I need a point on either side, right? So if I do f of 2, I get the cubed root of negative 4 times 2, which is the cubed root of negative 8, which is negative 2 minus 2, which is
My brain.
So what?
that's this end of it. Now I need the other end of it. So then I went the other direction. Do you see why I picked 2 and negative 2? I knew whenever I multiplied them by 4, they'd be a perfect cube root. So f of negative 2 would be the cube root of, again, you have your calculator. I'm doing this by hand, but lucky for you, you don't have to do all this by hand because you can calculate it. Cube root of 8 minus 2, which is 2 minus 2, there's your 0.
So actually, I already have 20 of them.
Okay. Now, domain and range on this one. Negative infinity to infinity. That's exactly right. X-intercepts. How do you know? Point crosses on the X. I could have used the calculator to calculate the 0. I could have put a 0 in for Y and solved it. It doesn't matter, however you want to do it. How about the Y-intercept? Negative 2. Both of them were negative 2. Extrema. None. Increasing. Never. Decreasing. Always. Negative infinity to infinity. In behavior. Always. Yeah. Okay, so on the right side of the graph, what's the graph doing? Okay. How about on the left side? If Miss Argandizzo escorts Davis, then I will escort, and yeah, and Teresa, your mama. One or the other. If one or the other agrees, yes.
Definitely not
He is not.
If Dizzy gets up there in a ball gown, I will.
Yes, no, maybe so. Let me graph number 8 for you quickly, and then we got to move on. Yeah. This one was kind of tough because you had so many things here with pertinent points that were included within the domain restriction important key point. That's what I had. I don't know what y'all thought now. Okay. Oh, I need a brain break. It wasn't just a toucher. All right. What? Do not encourage that behavior, Dozier. Do not. Okay. A cubic that is slid left 5 and up 2. My question is that key point. Think about a cubic, right? A cubic, remember you're supposed to know those parent functions like that. I know what I say. Okay. But my question is, if I take this and I slide it left 5 and up 4, is that middle point contained within this interval of numbers? Wait, yeah. This is 5, -5. Here's -3. This is my cutoff. So what I'm getting at is I need that middle point. I need the cutoff point, and then I need another point over here because look at what this graph does, right? Okay, so with that said, first thing I would do is plug in the restricted point, which is -3. When x is -3, what is y? -3 plus 5 is 2. 2 cubed is 8. -8 plus 4 is...
That's your first.
We're graphing this piece of this one. Yeah, I didn't put it in the parentheses. Okay. So, and I thought this one was the hardest to graph. All right, -3, -4, open dot because it's not included. Now, remember what this is. This is just this piece, this graph. This graph is doing this, right? I've only got this piece right down here. I need to come back and get this piece, and then I need another one over here. So it's easy to find that middle piece because I know all I did was go left 5 and up 4. So try it if you don't believe me. Put in a -5 for x, and what do you get for y? Cool. Be so for real right now. Yes. But you got to know where to cut it off if you put it in the calculator, because it's not the whole graph. I'm going to pick one more point because this is just that middle point. So maybe I think I picked -6. I don't remember what I picked. But if you put in -6, what do you get? The first one, I'm still in the first one. It's the hardest one. I got to.
Oh, no, it's 5.
So it just goes up. One more. So this is that cubic, and it's doing something like that. And you have to have enough of it to find that little twisty point there, that point of inflection. Okay. All right, the middle one. Again, this is a quadratic. This is an upside down quadratic that's been shifted up 2. Is my vertex contained within the range of numbers there? Yes, it is. So I need to make sure I include my vertex. What is the vertex? If you took this upside down parabola, shifted it up 2, remember I need any important points on my graph. This is the important point, and that's when x is 0, and 0 falls between -3 and 2. So yeah, it still stays 0, so when x is 0, what is y? 2, right? 0, 2. Put in your endpoints, so at -3, what is y? -7. 1, 2, 3, 4. Hold on a second. I'll put it in there. And that is filled in. And then I just need a point on the other side. I plug in 2, that's right, and I get -2 back out. The last is a line, it's the easiest. Plug in 2, you get -3. This should be an open dot, by the way. 2, 1, 2, 3. And then I've got a slope of -1, so down 1/1. Done. Yeah, this one's open. That's open on the end of that parabola. That point is 2, -2. Open. Quickly, and let's transition to your homework. Yeah.
I just don't know how to do this one.
2, C, and D. Okay. I'll start with 1D.
I just don't understand how numbers. I just don't understand how numbers.
All right. Stay with me. We were chatty yesterday. All right. So stay with me so we can focus, okay? F of x is x squared plus 2x. G of x is 5 minus x. I'm looking for 2 scenarios as I talk about domains. I'm looking for fractions and I'm looking for radicals. Because those are the 2 things right now that are going to create domain restrictions for me. If it's a fraction, I can't have 0 in the bottom. If it's a radical, I can't have a negative under a radical because I'll be in imaginary land. Okay. Square root. All right. Before we put anything together, I always stop and say, what are the domains individually? Okay, well, what's the domain of F here? It's a quadratic. It is -infinity to infinity. There are no asymptotes. There are no... What? What difference does that make? It's still going to be x times x plus 2. You can't just take it away and then can't factor it out and throw it away. No, it's a linear times a linear, which gives you a quadratic. That's like saying you're telling me, well, 6 is the same thing as 2.
No, I'm saying that is a quadratic and a linear. X squared plus 2x.
Can't break them out like that.
I forgot. I'm not trying to back.
Yeah, you can't look at it like that. You're overthinking that part.
Look at it and figure out what the
Yes.
Other than
If you transform it some. But all quadratics are -infinity to infinity, period. Yeah. Look at those 12 must-know functions, that packet that I gave you. Look at the domains on those. If the domain's not restricted on the parent function, it's not going to be restricted as you transform it. But if the domain's restricted to start with, then I'm going to be in kind of a tough spot trying to figure out the domain there. You could, like 1 over x. You know what I'm saying? Because it leaves out 0. You could. Okay, how about G? What's your domain?
Wait, so why are you doing it?
Huh?
Yeah, what's the fog log? I don't even understand that. Well, it's what it says on the back.
Stick with what I'm not going to give you anything that I haven't had you practice on. All right,
So that's also negative infinity, right?
that's right. Why? It's just a line. Lines have no domain restriction whatsoever. It's just a line. Yes? Okay, so what does that mean? That means I'm a graph that starts at 5, 1, 2, 3, 4, 5, and I go down 1 over 1, right? There's my graph. Left to right, what's the domain of that?
So why?
Okay, because I can't find a combined domain without the individual domain. So this tells me if I multiply, add, or subtract, my domain is going to be negative infinity to infinity. The only time I'm going to get myself in a situation is if I start dividing, which I'm doing here. Why does that put me in?
Negative. Oh, because
You have 0 on the bottom.
There's nothing left out of either one of them. So when I put them together, I don't have to leave anything out. Okay? But when I put them together, so look what I have. 5 minus x over x squared plus 2x. Now I have a problem. Before, I didn't leave anything out, so I'm on this whole number line, right? But now, what's the problem? I can't have 0 in the bottom. What values would I have to put in for x that would cause that to be 0 in the bottom? 0. If I put 0 plus 2 times 0, I would get 0 down there, right? I can't be 0. What else can I not be? That's it. Negative 2. How did you come up with that, Davis? You just looked at it and you could tell if you plugged in negative 2, right? But maybe I go back to my algebra roots and I say, I know that the bottom cannot be 0. So what would make it 0? Well, let's solve it for x and see. Now we factor it. Which is exactly what we came up with to start with.
That's all you gotta do. Factor in.
yeah, it's gonna get a lot harder.
In pre-cal, nothing's always just one way. If I leave out just those two values, what is my combined domain now? Yes. That is absolutely 100% correct.
That's for 1D?
Yeah.
Yes. Oh, nothing. You had that one. No, I was waiting on. I was just waiting on somebody to say something. I'm sorry. For some reason, this seat is like where I just always go there. It's in every. I'm sorry. I'm really not. It's in every class. It's just the way. No, that's not true. Poor Robert. He can't ever keep his phone in first block because it's Robert and Mac, and I see them every time they touch their phone. They do. They lost their bonus points today. They were big mad. Which other one? 2, C, and D. All right, here we go. Let me first, before we do any of the ones with 2, let's look at the domains individually. All right, let's look at F first. F. Why? This is the parent's 1 over x. At 1 over x, I have to leave out that vertical asymptote. Right. There's no shifts left and right. So the domain of the parent is the domain of this one. Okay? If you don't understand that, you can say, oh, wait, I have a fraction. I know I can't have 0 in the bottom of a fraction. What would make me have 0 in the bottom of the fraction? 0, right? So for this one, the domain is what? I always find the individual domains before I start. It's going to help you with the combined. What? No, it's not the answer, but I know I'm going to have to find the domains in just a minute. All right, look at this one, g of x. What's the domain of g of x? What's the parent function of g of x? It's a cubic. What's the domain of a cubic? Negative infinity to infinity. That will definitely help you. It doesn't matter if it stretches or shrinks. Right. When I put them together, so I can look back. So if I add, subtract, or multiply, my combined domain right now is going to be negative infinity to 0, 0 to infinity. Because that's not going to put me any additional variables in the bottom. That's because that has to do with shrinks and stretches. It doesn't have to do with shifting. All right, which one on 2 did you say now? C and D. All right, for C. C asked me to multiply them. So I've got negative 2 over x times 4x cubed over 5. Straight across. Yeah, no, that's okay. Which, I can take an x out of everybody, right? Okay, so now I have negative 8x squared over 5. It is a quadratic. And remember, quadratics domains negative infinity to infinity, right? But wait, that's exactly right. Look at you. Yes. But I have to go back on this one because even though if I just was given this graph and asked you for the domain, you'd say negative infinity to infinity. But because I used these two to create it, I have to include anything I left out of either one of those, I have to leave out of the combined one too. So I can't have 0 in there because in the beginning I left that out. No, you can have 5. That's fine. There's nothing else that I could put in there that would cause the bottom to be 0. So the domain here on this one is just going to be negative infinity 0, 0 to infinity. The point that I'm getting at is once you take it away, you can never give it back. I took a 0 away from F, and I can never give it back to F if I use it in anything at all. Does that make more sense? No? I took a 0 away from F in the beginning. If I use F to do any operation at all, I have to take a 0 out. I can't ever give that 0 back. I've already taken it away. So that means D, what is this, F over G? All right, so now I'm dividing, right? I've got negative 2 over x divided by 4x squared over 5. I'm going to do a little flip. Oh, sorry. I couldn't see. So negative 10 over 4x to the 4th. I can simplify that a smidge, right? Negative 5 over 2x to the 4th. There's my division. So domain. It's still just 0. Even if remember, I've already left out 0. I have to leave that out. Whenever I started the problem, I had to leave out 0. And because there's nothing else in the bottom that's going to cause me any type of restriction, that's all I leave out. Yep. Okay, now go ahead. Yes, but in this fraction, if 2x to the 4th equals 0, it is 0. I've already left that out. I don't have to leave it out again. So maybe if I combine them and I had gotten -5 over, let's just say x plus 1 whenever I did it. Let's just say that's what I got. Right. So this one, remember I already left out 0, so I still got to leave that out. But now I also have to leave out -1. So I need to leave out negative, and I have to think about this sometimes on a number line. If I have to leave out -1 and 0, then I'm going -infinity, -1, -1, 0, 0, infinity. This is just, she said, what would it look like if you had to leave something else out? Every time you leave out a single value, this is how you do it with back-to-back parentheses, every single time. For 3. So 3 starts getting into the radicals. And if you notice, that's basically what I'm focusing on here for domains, right? There's a, yeah. All right, so number 3, f of x is the square root of x minus 7. g of x what's the domain of the first one? 7 to infinity. You can think about it graphically. You can think about that parent that's at the origin that I just moved right 7 times. Or you can think about it as this has got to stay greater than or equal to 0. So my domain here, 7 to infinity. Yes? How about the domain on G? Anybody confused on that? Okay, so when I have a radical, it doesn't matter what's under here. Whatever's under there has to be greater than or equal to 0. And you just solve that inequality. If I say x minus 7 has got to be greater than or equal to 0, that means x has got to be greater than or equal to 7. Because I can't have a negative under there because then I'm an imaginary number. Yes, it looks just like this. That's exactly right. And if you can visualize that and you know that it's just that and it's moved over 7, that's perfectly fine. You don't have to do this algebraically. All right. Do what? A? I feel like we did this one yesterday. Okay, so for this one, I'm adding them together, right? Only I can't add those two things together. They're not like radicals. Does that make sense? I leave it. I can't do anything else. I stop. Stop right there and leave it. But now I need the combined domain, so let's think about this for just a minute. If f has to be bigger than 7, and g has to be bigger than 0, and if I leave something out of one, I have to leave it out of both. So it's what they share. It's the area that they share. Think about it on a number line. Here's 0. Here's 7, right? One of them's got to be bigger than 0. The other's got to be bigger than 7. So what do they share? It can be 7. Yes. See, it's what they share. This one, okay, let's make this one a different color so you see. Where's the pink and the green? 7 and bigger. Because if you leave it at a 1, right? Right?
Why
Any-
7?
Yeah, I'm gonna try. Yeah, no, you can.
Huh? Okay, so could you put 0 in this one? No. So if I
Oh.
can't put it in both of them, I can't use it. That's right.
So why is that?
Why what?
Don't you have to show?
It's what they share. What? Yes. Right. Okay. So, right. You're right. Okay. So look, F excludes anything smaller than 7. I can't have any of this. That's what F excludes. G excludes anything smaller than 0. If it's excluded at all, I can't have it when I combine them. So I can't have any of this because it's excluded in one of them, which means I have to start right here. That means all of this is fair game. So either look at what they share or look at what they both leave out, whichever's easier for you to see. Right. Right. Yes. Yes. I do want to look at D because I want to show you what happens here because yes, it's very similar, but it's a little bit different. I'll show you. D, and then I'm going to come back to C. If I divide them, so I do the square root of 2x over the square root of x minus 7. I've suddenly got myself into that other situation that can't happen. What is that? Cannot be 0 where? In the denominator. What would make me have 0 in the denominator? 7, right? So now all of a sudden, do I have this same domain, but now not only can I not be any of this on this side, I also can't be 7. So how do I say that? Exclusive, you're exactly right. So I say start at 7, but don't be 7 because 7's bad. And go to infinity. No. If you put 7 in there, you get 0 on the bottom, undefined. C asked me to multiply them. What I have, square root of x minus 7 times the square of 2x. This time I can put them together because they're multiplying and it's the same radical. So I could make this the square root of 2x times x minus 7. Right, right. But my domain's still going to be the same, my restricted domain. I'm still going to be bigger than 7. I wouldn't make more work than what I had to do. If you want to, I mean, it's not wrong, 2x squared minus 14x, you could. I'm still going to have that same domain. Yep, that same combined domain. Huh? Yep, yep.
Why are you still going to have the same? Oh, it's not a fraction.
It's not a fraction. It doesn't matter. Can I get the square root of 0? The only reason it was a problem here is because it'd wind up in the bottom. So this is just the combined domain. I didn't do any additional work for it. Yeah. Oh, C. I'm talking about B or C. Okay, C, I haven't done anything additionally to it. There's no other restrictions there that I need to worry about. It's not on the bottom. I just combined them. Because it makes a difference with radicals. Yes, so this one could be 7. 7 would cause me to have the square root of 0, and that's okay in this case. But in this one, it's not okay. And it's not okay because I can't have a 0 on the bottom. No, that just leaves out only the 7. D, it can't be 7. It's still that whole range of numbers, but it can't actually be 7 because if I plugged in 7, you can go, David. If I plugged in 7, that would give me 0 on the bottom, and that would be undefined. Like if you put a 7 in here, what's going to happen? 7 minus 7 is, I'd have the square root of 0. Square root of 0 is fine, but in the bottom, that gives me a denominator of 0, and that's no bueno. Exclusive. All right, pick one, 4 or 5, because let's do this, and hopefully after I explain it, you'll be able to do it on your own. Okay. Too late. It was too late anyway. I don't show right now. H of F. So this is, all right, let's do our individual domains first. Because we have to do domain on this also, right? Yes. What's, there you go. What's the domain here?
Don't have a clue.
It's a line. Come on, just guess. Negative infinity to infinity. Oh, Noah. If it's a line, a quadratic, a cubic, look at those parents. These are all negative infinity to infinity. Good grief. All right, so this is H of F of X. That's what HOF means.
So half means H of F.
Yes. That means I'm going to take F, and every X in H, I'm going to replace, okay? It doesn't matter what's in the parentheses. I'm replacing every X. So I'm going to take F, and I'm plugging it in for that X, okay? So I'm taking F. All right, think about it like this. If I asked you to find H of, I don't know, Y, what would you do?
You put Y in.
You put Y in, not the H's, but the X's in H, right? This would be 2Y minus 5.
I got that.
Okay. What's H of Noah? What do you do? What's the process? Put Noah inside H for the variable, right? It's going to be 2 times Noah minus 5. It doesn't matter what's in the parentheses. It doesn't matter what's in the parentheses. It replaces the X completely and totally.
I don't know which one's replacing which.
The one inside replaces the X's in the outside one. Look. No. Look, Noah replaces all the variables in H. Okay.
So now
Okay.
Alright. So you put X3 inside of X3 plus 6 inside of
All right. Always work inside out. Okay. Start inside. Inside out. So F of X is X cubed plus 6. Yes? Say yes, because that's right. I've lost about a third of you. All right. So X cubed plus 6 is replacing every X in H. Okay. So I'm going to take H. H is 2X minus 5. It's 2. Uh-oh, it's not x anymore. It's minus 5. Do you still see the equation there? 2x minus 5. I can clean it up a little bit. 2x cubed plus 12 minus 5, which is 2x cubed plus 7. But what is my domain? I got to look at the combined domain. Remember, negative infinity to infinity. This is another combined situation, and I do the same exact. This one is easy.
So the way to tell that.
So this one, so it's the same as.
The pre-cal part comes from the combined domains, and then whenever we start using functions that are
You're crazy.
I'm not lying.
This is harder than
Composition is an algebra 1 concept. Now we build on that and we get harder as we go, but yeah. But as far as the plugging into something, well, you wouldn't plug into a cubic in algebra 1. You'd have a linear into a linear, or even a quadratic, but you wouldn't. Okay, let's do part B. Part B says h of g of x. Okay, so let's rewrite it because I think it's a little easier to see like this. H of g of x. Inside out. How do I know what? Because I write it just in the order that it is here. H, this means of, g of x. Inside out, furthest inside. We're going to get to some here real soon that are multiple compositions, h of g of f of x. So, but we always stay as far inside as we can first. You always work inside out, inside out, inside out, inside out. So furthest inside, what is g? Okay. X cubed, nope. Oh, wait, I didn't write it. What is g?
What? Cube root of 4x.
Oh, sorry, I'm looking at the
Okay. So it's cube root 4x. That is, you're exactly right. Thank you.
Yeah, he's right.
Yes, because you already jumped ahead, Noah.
No way.
Yes, you have. So now, whenever I plug that into H,
Well, h is 2. Here's what I'm replacing x with.
And then it's negative infinity equals negative 1u minus negative.
Whoa, 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 whoa,
That's how
whoa.
they always work. How do you go from numbers to? I'm gonna get everything.
That's a cube root, though. Cube roots can be negative under there because what's the cube root of a negative number? Another negative. Because a negative times a negative times a negative gives you a negative.
So if I put
Yeah. Well, if you've got the combined one, yes. Because it's a cube root, look at your cube root parent graph. There's no restriction on that. What'd you say, Noah? Or does there somebody say something? Okay. Well, let her see. C f of g of x. So I've got f of g of x. This is C. Yeah, we're still. Oh! G of f of x. Sorry. All right, so I put what? Inside out, inside out. You can do it. You can do it. You can do it. Inside out. Always go inside first. So g of x cubed plus 6.
That's what this is. It looks like that.
Cubed root of 4. That's your g. That's it. Nope.
Why not?
All right, let me tell you what I'm going to have you do.